Today's lesson is on how to reclassify numbers. We're going to look at this chart for the different types of numbers. The first set is real numbers. So real numbers is what we're going to be talking about throughout this year. Real numbers can be split up into two options. They can be rational numbers or they can be irrational numbers. Rational numbers can be expressed as a fraction. So any fraction, 2 over 3, 4 over 7, those are rational numbers. Or a whole number, 5, 8, those are rational numbers. Or they can be decimals that repeat or ends. 2.5, 4.3, those are rational numbers because the decimal ends. Or if the decimal repeats, like 4.3 repeating, that is a rational number. 6.72 repeating, that is a rational number. As we learned yesterday, we're able to convert these repeating decimals into fractions, so that is why they are rational numbers. Irrational numbers are numbers that are not rational. So a decimal that does not repeat, like 4.24678913, that does not repeat. A decimal like 4.2323323333, this has a pattern, but it does not repeat. A number like pi, that is also an irrational number. And any number you take the square root of that is not a perfect square. So the square root of 10. Since 10 is not a perfect square, that is an irrational number. Now, rational numbers can be split up into two categories. They can either be non-integers, so fractions or decimals, or they can be integers, which are positive and negative, non-fractional rational numbers, including 0. So anything positive or negative, -2, -4, -100, 0, 1, 4, 19. Those are all integers. Integers then can be split up into two categories. They can either be negative numbers, which is just a negative integer, like -2, -4, -100. Or they can be whole numbers, which are positive integers including 0. So 0, 1, 4, 19. Whole numbers can then be split up into two categories. They can either be 0, which is just 0, or the natural numbers, meaning the counting numbers, like positive whole numbers, 1, 2, 3, 19, 35. Those would be your natural numbers. Take a second to make sure you have this chart and the examples written down. Problem 1. Classify each of the following numbers as rational or irrational. We have 5 options, so take a second to copy down the questions and the 5 possible questions. The first number we're going to look at is 0.45454545. If I look at this number, the 4 and 5 is repeating. I have 4, 5, 4, 5, 4, 5, 4, 5, 4, 5. Since this number is repeating, this would be a rational number. The next number, 9.2324252627. If I look at that number, the 2324252627, that's a pattern, but it is not repeating, so this would be an irrational number. The next number is pi. As we learned in our chart before, pi will always be an irrational number. The next example, 67 over 73. Remember that a rational number is any number that can be written as a fraction. So since this number is a fraction, this would be a rational number. And the last example, 23.4 repeating. Since this 4 is repeating, I have a repeating decimal, so a repeating decimal will always be a rational number. The second problem, classify each of the following numbers as rational or irrational, and I have 4 square roots. Take a second to copy down the question and the 4 problems. When you're determining if a square root is a rational or irrational number, you need to determine if the number under the square root is a perfect square and will equal to a whole number or not. If it equals to a whole number, then it is rational. If it does not equal to a whole number and it is not a perfect square, then your number is irrational. My first example is the square root of 100. 100 is a perfect square, so the square root of 100 would be a rational number. The second example is the square root of 15. 15 is not a perfect square, so the square root of 15 would be an irrational number. The square root of 42. 42 is not a perfect square, so the square root of 42 would be an irrational number. And the last example, the square root of 1. 1 is a perfect square, so the square root of 1 would be a rational number.